All right, so in these next two examples, we're going to look at what happens when we combine a vertical and a horizontal translation together. And you're going to see that this is very similar, or pretty much exactly the same as what we did with the absolute value functions. So the vertex of this graph here, we're going to move it 1 to the right, and then 18 up. So the vertex becomes the point 1, 18. Okay? So that is where the vertex is. So I'm going to go ahead and plot that point here. So we're going to be pretty close to the x-axis and a ways up on the, so that's 1 and 18. Now, just like with the absolute values, this -2 out front tells me that this is going to open down. Okay, so this point 118, that vertex becomes a maximum, or the highest point on this graph, instead of a lowest point like we saw in the previous two examples. Again, to find the y-intercept of this graph, we just want to plug 0 in for x. And then do the arithmetic. So, doing the arithmetic, we have -1 squared is 1, times -2 is -2, plus 18, 16. So there's our y-intercept, which will be right up here, and that is the point 0, 16. So one branch goes that direction, so the other branch symmetrically goes the other direction, and it looks the same on both sides. Since I'm touching the screen, I'm getting a few stray marks here that I will get rid of. And then the last step, finding the x-intercepts, once again is okay, continuing on, we found the vertex and the y-intercept of this graph. To find the x-intercepts, once again, just like with the absolute value, we are going to substitute 0 in for y. So what we're going to do is we are going to get this squared part, this piece right here by itself. And we're going to do that by subtracting the 18 and dividing by -2. So then 9 is going to be equal to that squared portion. And then to undo the square, you take the square root. So x minus 1 is equal to 3. But it could also be equal to -3, because if you square -3, you also get 9. So any number other than 0, any positive number other than 0, always has two square roots, the positive and the negative. So then, what we're going to do is we are going to solve for x. So if we add 1, okay, if we set it up this way, just like we did with the absolute values, we're going to add 1 to everything. So -3 plus 1 is -2. 3 plus 1 is 4. So there are our two x-intercepts. One of them is 4, 0. The other one is -2, 0. And the domain, once again, -infinity to infinity from left to right. And the range goes from bottom to top. Well, the bottom of this graph is -infinity, and the top of the graph is the y-coordinate 18 of that vertex, which is a maximum. And finally, the last example, the vertex of this graph, we're taking the vertex, moving it 2 to the left and 8 down, so the vertex is the point -2, 8. Which puts us about down in this area. -2, -8. And to find the y-intercept of this graph, plug 0 in for x. And then do the arithmetic. So 0 plus 2 is 2, squared is 4, times 2 is 8, 8 minus 8 is 0. So that is the y-intercept. And as it turns out, that's also one of the x-intercepts. So the other x-intercept, one way we could find that is, again, parabolas have symmetry just like the absolute value functions. So we travel 2 to get to the vertex. So 2 more, we would end up at -4, 0. And again, you could find that by not paying attention to the symmetry. Again, you can plug 0 in for y. Get the squared portion by itself by adding 8 and dividing by 2, so that's equal to 4. So then x plus 2 would be equal to the square roots of 4 plus or minus 2. So that means x plus 2 is either equal to 2 or -2. And we would subtract 2 to solve for x. And that's how we get the -4 and the 0. And finally, the domain and range. Domain is -infinity to infinity. And the range, the bottom of the graph is -8. Top of the graph is infinity. Now, the form of the equation that we were working with here is what's called vertex form, because our vertex is right there in the equation. Tomorrow we're going to look at graphing out of standard form.